Okay, now we're going to start learning about a double angle identity. And all of these identities are when we have to find the value, numerical value of an angle when it doesn't exist on the unit circle. So remember we were just doing the pi 12s? Well, pi 12 angles are not on the unit circle. So there had to be other ways to come up with, well, what would be the numerical value? Remember, calculators have not been around very long. Um, Computing devices have not been around very long. Okay, so the double angle identity, first of all, on your note sheet, in the section where it says double angle identity, it says sine 2 theta, that means twice as wavy. To find the value, you multiply 2 times the sine of theta times the cosine of theta. So here's the trick. We have to figure out what the theta is. And this is how I did that. The information they give us is cosine theta is negative 4 over 5. Well, remember, that's the adjacent. That's the hypotenuse. So I know that I went negative 4 from 0. I went over negative 4. So this distance, that adjacent side, is negative 4. The hypotenuse is 5. Well, this is a Pythagorean triple. So I know automatically, remember the Pythagorean triples, 3, 4, 5. And it doesn't really matter if that's negative, because negative 4 squared is positive 16. So it's okay that we went in a negative direction. The 3 is in a positive direction. So now, what is sine theta? So let's go ahead and put sine theta is 3 over 5. Well, according to the identity, we only need to know sine and cosine. So we can now, if we double that angle, so whatever the angle this is, well, let's pretend for a second it's not, but let's pretend it's 91 degrees. If we double it, it'll be in this quadrant. Well, sine and cosine are both negative in this quadrant. If it's 179 degrees, so still in the second quadrant, we double it, we'll end up down here someplace where the cosine is positive and the sine is negative. But right now we're dealing with the second quadrant. The cosine's negative and the sine is positive. So sine 2 theta is equal to 2 times sine theta times cosine theta. I would want to see that written out on your paper. And then again, sine 2 theta. And now you fill things in. Well, sine theta is positive 3/5. Cosine theta is negative 4/5. And then this is where you can just multiply using your calculator. I know that 5 times 5, that's the only thing in the denominator. So we know we're going to have 25 in the denominator. We also have a positive times a negative, so there will be a negative sign out front. And 2 times 3 is 6. 6 times 4 is 24. So just like that. All right, I'm going to pause this. Okay, now we're going to look at the double identity for cosine, but buckle up. There are 3 different versions of that function. So cosine 2 theta equals cosine squared theta, subtract sine squared theta. That's one of the identities, or one version. You also have cosine 2 theta is equal to 2 times cosine squared theta subtract 1, or you have the version that's 1 subtract 2 sine squared theta. These are your 3 options. So here's the cool thing though. You look at the information they give us. We don't even have to worry about finding sine, because look at this function right there. All we have to know is cosine. So we can say cosine 2 theta, we're going to use this version, is 2 cosine squared theta subtract 1. So I'm going to write it again, but this time fill in the values. So 2 times, so cosine theta squared, well, cosine is 2 root 5 over 5, and now we're squaring it because of this. We have to square it, and then we subtract 1. So over to the side someplace, do 2 root 5 over 5. That means each part gets squared. The 2 gets squared, the root 5 gets squared, root 5 times root 5 is 5, and then 5 gets squared. Well, 5 squared is 5 times 5. Well, that cancels, and what we have left is 4/5. So now I can write 2 times 4/5, subtract 1. Well, when we subtract 1, if 5's in the denominator, I can rewrite that as 5 over 5. You guys kind of following along? We just use this identity where it says cosine theta. I plugged in the 2 root 5 over 5, and then I squared it. Over at the side, I just squared each piece. 2 squared is 4, root 5 squared is 5, and 5 times 5 the other way, just multiply across. 4 times 5 is 20. 5 times 5 is 25. You plug that in your calculator, 20 fraction 25, and you get 4/5. So now we can plug this thing squared. It's simplified to 4/5, and now we can multiply across. So 2 times 4/5 is 8/5. So 8/5 subtract 5/5 is 3/5. So cosine of 2 theta is 3/5. So this is what that means. When we doubled this angle, when you double it, it still ended up in the first quadrant because the cosine of the double angle is positive. If it would have doubled, if it would have been like a 70-degree angle and it would have doubled to the second quadrant, we would have had a negative answer. So this could have been like an 11-degree angle, and when you double it, it's 22 degrees. And so, but it's still in the first quadrant. So the cosine of that double angle is still positive, so it's still in the first quadrant. Okay, so we have another cosine, and remember the 3 double angles, cosine squared theta. So cosine 2 theta equals cosine squared theta minus sine squared theta, or 2 cosine squared theta, subtract 1, or 1 subtract 2 sine squared theta. Well, they give us cosine again, and cosine, we are in the fourth quadrant between 3 pi halves and 2 pi. Well, yeah, cosine's positive. But when you double, let's double an angle really close here. So let's say 271 degrees plus 271 degrees. Well, that's going to be 542. That angle would end up here. So when you double an angle that's here, you end up in the third quadrant. But if you're really, really close, maybe it's this angle right here when you double it, you end up back in the fourth quadrant. So your answer, the cosine's either going to be negative or positive. I won't know until we finish it. So let me go ahead and erase this right here, and let's see what we can do. I'm going to change the color. So cosine of 2 theta, that's got to be in parentheses. I'm going to use this theorem again because they give us cosine 2 theta. So it's 2 times 2 root 29 over 29 squared, subtract 1. Well, over to the side, 2 root 29 over 29 squared. Well, 2 squared is 4. Root 29 squared is 29. Root 29 squared, the square goes away, but 29 squared is 29 times 29, and look at those cancel. So now this just becomes 4 over 29. So 2 times 4 over 29. Now we're going to subtract. Since 29 is in the denominator, when we subtract 1, we can write it as 29 over 29. So 2 times 4, we have 8 over 29. Subtract 1, or 29 over 29. Well, when we do the subtraction, 8 subtract 29 is negative 21 over 29. So cosine, and you really should be doing that the whole time. I'm just trying to save time. I know that's what you say too, but I need to see your understanding. So guess what? Because cosine's negative, we know that when you doubled this original angle in the fourth quadrant, when you doubled that angle, it must have been around, that angle must have been around here, because when you doubled it, it ended up in the third quadrant where cosine is negative. Okay, they're not always going to use this theorem, so I did not check this very carefully. We'll be practicing others where we use this version. Well, actually, the cosine squared theta minus sine squared theta often doesn't get used here, but we end up using it in equations later. These two versions are the ones that typically, because look at, this has only sine, this has only cosine, so these are the two easiest to use for the double identity. So cosine, let's see, first let's decide which quadrant. We're between pi and 3 pi halves. So third quadrant, yep, where cosine's negative, so sine, but cosine's negative. When we double this, we could end up in the first quadrant. Let's see, 181 and 181 is 360 something. Yeah, so the first quadrant and maybe the second quadrant. So I'm not quite sure whether the answer is going to be positive or negative. So we just plug it in. So it's 2 times. Well, the cosine is negative 1/2 squared, subtract 1. Well, this one's really easy. Negative times negative is positive, and 1 squared is 1, 2 squared is 4. So we're going to subtract 4 over 4. I'm going to leave the 4 there instead of simplifying, because now we have 2/4. Subtract 4/4, which is negative 2/4. So cosine 2 theta ends up being negative 1/2 again. But originally we were in the third quadrant. When we doubled it, we ended up in the second quadrant because you didn't, yeah. So, and in the second quadrant, it's also negative. Okay, that's it for now for the double angle identities. Again, we didn't do a tangent, but we've done 3 versions of cosine, not 3 versions, 3 examples of the same version, and one of the cosine, one of the sine, and we'll do tangent probably next week.